Okay, we're going to be going through calculation of gas laws. We got three separate ones we're dealing with. All of these are the standard ones. So I will go first with this one. This is referred to as Dalton's Law. It's not really important to remember who made the law, but it is the parts of it that are actually important in the calculation. So basically it's a very simple law. You've got pressures of different gases, and it can be more than 3 pressures. So we got this here that represents that, and that will equal a pressure total. There are 2 ways to calculate it. If you're figuring out your pressure total, you just do what's here. If you do have a pressure total, then you're just going to subtract this part. So it'd be kind of like in the opposite direction. On this one at the top, what you're going to notice is you're going to notice in your sentence probably 2 different volumes, which is this, or 2 different temperatures in it, which is this. But if you're seeing 2 separate of this and 2 separate of this, that is how it works. This part, since it's consistent with this part here, probably not the best indicator. On the bottom, if you're dealing with moles or grams, this is the formula you're going to use. You're going to notice I got 2 separate units down here. That is for advanced chemistry. Now, if you're kind of looking at this number here, that is considered a constant. It doesn't change, so it would go in here. You also have requirements. My pressure has to be in atmospheres, volume is in liters, and temperatures in Kelvin. Now, if you're going to need more specifics as far as how to convert and everything, you do have a PDF or a PowerPoint in the last weeks of the third 9 weeks, so you can take a look at that. It tells you specifically how to convert. But again, we are kind of concentrating on how to calculate these things. And I'm only going to go through a few examples. So we're going to start with number 1. If you are on the online class, you actually have this worksheet in there. You guys are going to have to show your work and submit it through Google and the sharing. And I shared with you in the third 9 weeks in your email exactly how to do it. It needs to be organized so I can find it. So if you need more information on that, you're going to need to let me know. So we're going to go number 1. It's going to ask for how many moles of a gas. Well, if it asks for moles of the gas, or if mole shows up in any place in your sentence, then this is the formula I'm going to use. So we're going to put this here. Pay attention to your worksheet as you're going through it. Some people like to write down all the units and stuff on the side. That is fine. But right now, what I have to do is just pop the numbers in here, making sure they're in the correct unit. So if I'm finding the moles, this is my number of moles, which will be N, because that's what it's asking for. Then I go one by one and put the units in, or the numbers in, as long as they're in the correct unit. So I got 98 liters. You know liters are good, so we're going to put 98 in for here. Now we got a pressure, or a P, of 2.8 atmospheres. That's good. My R value, sometimes I just like to pop that in first as a reminder. And then I have a temperature of 292 Kelvin, which again is the correct unit. So if I'm taking a look at this, now I have it set up in a very easy calculation. I group my things together through multiplying. So I got 2.8 times 98, which equals 274.4. Then I take care of that 0.0821 times 292, and I've got 23.97. And then I'm going to solve for n, which means the n has to be by itself with no numbers, so I got to get rid of that. Algebra rules apply. If I divide 1 by 23.97, I also have to do the left-hand side also. Takes care of that, and then my n, which is my number of moles, then I just divide. And I have 11.4 moles. Now, as far as the rounding, we are dealing with different numbers, a whole lot of different numbers. So we really don't have to worry too much about the rounding part. You'll see it in this. Usually when you're dealing with moles, you want to be a little more accurate on your number. So you could put 11.4 or 11.45, and that will work. Now, of course, if it asks for grams, let's say it asks for how many grams of hydrogen gas, and that's hydrogen gas, H2, then you're going to add to it. Now in number 1, you're going to notice it just asks for moles, so that would be my endpoint, but if I extend it, I can go 11.4 moles. Following pattern, mole bottom, gram top, big one, mole, mass of H2, 2 times 1, 2 grams. So if you're going to calculate this out, we could end up with 22.8 grams of hydrogen gas. Let's go on to the next one. So let's go to number 3. If you're looking at number 2, it says something and something. You do not have to do 2 separate problems or 2 separate PV equals nRTs because it mentions moles. You can just take your 5 and 3 and do what you think you need to on that. Let's go number 3. Now if you take a look at that one, you're going to notice you have a volume and you have 2 temperatures. Well, I have a volume, 2 temperatures, I see 2 temperatures, that is my formula. Let's go ahead and set it up. And again, we're trying to do the minimal amount of work on this. If you take a look through your sentence, you're going to notice that there is no pressure. So listen carefully. If there's no pressure, we don't use pressure, but we use the same formula. So I'm going to just start with this. Usually these things are set up as far as the sentence. Sometimes you have to look a little closer, but if you take a look at the first sentence, my volume and temperature are actually grouped together. So they're going to go on the same side. So I'm going to put my first volume here, and then the temperature is 20 degrees Celsius. Celsius doesn't work because it needs to be in Kelvin. So you're going to have to put 20 plus the 273. And I will tell you the exact reason why in a little bit. But this is the only number that's actually going to work here. So every time you see the word Celsius, you have to add 273 to change it to Kelvin. Now the temperature rises to 45 degrees Celsius. In gas laws, things have to be the same unit on both sides. So this is what I'm going to do with that one. And then I'm going to be solving for V2. And that takes care of your changing them to Kelvin. Pretty simple. Now if you're in math class, you're going to notice that this is set up as a multiply and divide. We call it the cross multiplication and division. I'm going to go ahead and bypass all the writing of the numbers. I'm going to go ahead and multiply these two first. I'm going to have a total number, and then this would be 293 V2. So we got 11130 divided by 293. And I end up with 37.986. Again, we want to kind of minimalize this one, so we're going to go 38, or it could be 38.0 liters is my volume 2. Again, rounding rules are kind of flexible with this one. Usually if you're dealing with something really close to here, I just go 38 or 38.0. Either way works. Okay, let's go on to the next page. Again, you'll notice these are kind of simple. Number 6, kind of point that one out. Sometimes you're going to have things in there which are like comparison numbers, or you're going to have restated numbers in your sentence. Now in this case, if you take a look at number 6, we have a restated number. They're only concerned with carbon dioxide gas. So you look at the first sentence, and usually that's where it's going to put your statement. So in number 6, we could consider the 1200 degrees Celsius as a statement. The last part is the part that's important. So I'm going to set this up all the same way. You're going to notice that there's no pressure, so again, we don't use pressure. And we set up our numbers this way. So I got 25 liters, and then it's at 1200 degrees Celsius. Celsius doesn't work again, so we're going to add 273. And there's my Kelvin. Or some people like to say Kelvin. Now if we go to the other side, we're going to notice that we are finding the volume. So that'd be V2. And then my temperature is going to cool to 25 degrees Celsius. And again, we have to add 273 to change it to Kelvin. So again, we're all set up, and it looks like this. Now, if you're dealing with this type of thing, temperature is the only thing that's ever going to go on the bottom. So do not put a volume or a pressure down at the bottom because it doesn't work. Then we do this. Then we do this. Again, I'll set this up. I'll just change it back and forth. Then we're just going to go ahead and divide, getting the V2 by itself. You're going to notice that these are pretty easy to deal with. Sometimes we have to deal with relationships, but I'm going to go ahead and write this in next. So it's 5.1 liters for my volume. Now, if we're dealing with a situation like this, when I have the temperature down at the bottom, we refer to this as a direct relationship, because as I go from higher to lower temperature, this one gets lower, and if I go from here to here, that one gets lower. So it's kind of equivalent to having a balloon that's hot, putting it in the freezer, gets colder, the volume gets smaller. Direct relationship. Now let's go with the last one, which is number 7. So we have a whole set of numbers. Now this one's one that people have a lot of problems calculating, so I'm going to kind of show how to do that. Again, you're going to notice your grouping. The first set's going to be 1 atmosphere. And I got a volume of 4.5 liters. I usually put the multiplication in as a dot. And then 20 degrees Celsius. So here's my Kelvin. And I take care of that. Then I go over to the other one. The pressure is 0.600 times E2. Just be flexible because I'm showing a lot with the volume. And then I got a negative 20 degrees Celsius. The problem is the situation doesn't work with a negative 20. That is why we add 273. So if I have a negative 20 or a 0 or anything that's negative by way, I have to add 273 because we don't want to deal with negative volumes or negative pressures, because that doesn't work. Now we can have a negative Celsius as you see here, but if you're calculating, you can reverse from Kelvin to Celsius by subtracting 273. So just remember, if I'm dealing with this and I want to figure this, I have to do the exact opposite of what my formula shows. So I add these up. Just remember that this one is lowering by 20, and I got 253. That is my number that will go here. Again, it should be rather simple. Now I'm not dealing with the middle one. Now with regulars, the middle one's pretty easy. There may be some of the sorted problems, but you're just going to notice a bunch of pressures. For the most part, we're going to have the top and the bottom ones. Now again, the setup may be a little bit confusing, but it is a cross multiplication and division. So we're going to go 1.00 times 4.5. I'll set this whole thing up. And that equals 293 times 0.600 times V2. Take care of the left side. .5, and I got 293 times 0.6. 175.8 times V2. Divide both sides by 175.8, like we do normally. Cancel that out. V2 equals 1138.5 divided by 175.8. And I've got It's 6.47. I'm going to go 6.5 liters. So this shows you how to do all the stuff on the worksheet. All the rest of the problems, every single class is going to need to show all the work. If you don't show all the work, I just return it. So just make sure you show it, and I can look at it very quickly. By the way, let me make sure I got the correct one. Number 14, go ahead and give it a try. It is actually a percentage, and you got to make sure that you take into account the whole volume. That is your hint for doing number 14. Good luck on number 14. I'm not sure how I'm going to put number 14 in. Maybe do it as an extra credit thing.